these in slope-intercept form like this. They're in slope-intercept form. To do this type of problem, and it doesn't have to be perfect, graph the first one, y-intercept, y-intercept of -3, the second number. Slope of 1/2, the first number. So, from -3, you go up 1 over 2, up 1 over 2, connect your dots. There's the first line. Yeah, it's kind of horrible.
So, are we reviewing or is this something we haven't done before?
No, this is review. We've done this. The second one, y-intercept of +1, slope of -3/2, so down 3 over 2. Oh, you can kind of see where they cross right there. You have to graph the lines and eyeball where they cross. Well, this one's not so bad. Looks like it crosses at 2, -2, so that would be the solution to this problem. If you think that's something you can do, put a star on your paper, and I'll take volunteers for that in a minute. Again, I'm not going to spend much time on these because you're always welcome to go back and look at the video I'm going to post and watch. Let's say you volunteer for this problem. You can watch me work through this problem 800 times, and then you'll be prepared for tomorrow. 800 times would take a while. Questions? All right. Again, all you have to do is follow along and put down the work and answers.
Oh crap, I didn't do that.
Because I'm going to look at these on Wednesday for a free homework grade. So, you just need to be following along, putting down, and this is due for you when you get back, so you might as well follow along too. I'm not saying you're not, I'm just saying I'm going to give you a grade.
Do we need to make the graph part 2?
Yes. Yes. If you volunteer for this question, you're going to have to make the graph tomorrow.
Oh no, let me write this down.
Sorry. Got FaceTime? Can you use the answers?
No.
Well, can I FaceTime a student and give the answers?
No.
No, cool.
That would be cool.
That'd be a cool way to use the technology.
Yes, it would, but it wouldn't be productive for the other 25 people. All right, here we go.
No. Sorry, I'm slow.
I'm drawing on the board for you know something.
Just sketch the graph and write down 2 negatives. All right, next one. Number 3. Solve with elimination.
Process of elimination.
Kind of. Elimination is the one where you multiply both rows. Now, Jack, Daniel, I don't know why I called you Jack. Would you rather get rid of X or Y? I don't care. Pick one.
That's a bigger one.
Let's get rid of Y. What? Well, he chose Y, so we're going to go with Y. What is a number that both 5 and 6 go into? 30. 30 is an excellent one. So what do we need to multiply 5 by to make it equal 30? 6. What do we need to multiply 6 by to get it to equal 30? Now, one of these is going to have to be negative because neither of them is right now. So let's make the top one -6. So if I multiply the top row by -6, it gives me positive 18x minus 40, oh, just kidding, 30 y and positive 24. That's if I multiply everything in the top row by -6. If I multiply everything in the bottom row by 5, that gives me negative 25x plus 30y and negative 45. Now, the whole point of this method is so that you can now add these. 18 plus negative 25 is negative 7x. Negative 30 and positive 30 cancel, which was the point. 24 minus 45 is negative 21. How do I finish this up? Divide by -7. That's perfect. And what will it be when I divide by -7? 3. Very good. If I take that 3 and plug it into one of my originals, I'll plug it into the top one. So that's -3 times 3. I'm plugging this into the top equation. Plus 5y equals -4. Let me change colors to help us follow this. So that'll be -9 plus 5y equals -4. Add the 9 to both sides. You get 5y equals, what's -4 plus 9? 5. So divide both sides by 5, and y equals 1. So the actual solution to this is the coordinate 3, 1. X is 3, y is 1. I apologize for the bad handwriting. I'll try to go slower.
Yeah, stand.
Touche. Touche, sir. Questions on that one?
No matter which problem you plug your,
No, sir, it does not. It does not. Mean the x?
Yeah.
Nope. I just chose the top one.
X or Y.
Well, I mean, it gave us, we had x, so we had to plug it into the x. But we got,
Like whenever you start to solve, though, you start
Oh, no.
with X, you start with Y.
yeah, it doesn't matter.
You just wanna eliminate them.
Yes, sir.
Okay.
All right. We good? Next one.
Discard.
All right. Solve a substitution. Now, I've gone ahead and put these in a form that would be advantageous to the method I'm telling you to use. Substitution's good. Why? Why is substitution good for this one? Who remembers?
Because subtract.
Because there's a variable that's a-
Exactly. We already have a variable that's solved for. Y equals. So, I'm going to take what y equals and plug it in for this y. So, 3x minus 3 times x plus 4. I'm just plugging in what y equals for that y equals negative 12. So that's 3x minus 3 times x minus 3 times 4. What happens here?
the
3x minus 3x. What happens?
Combine.
It cancels. 3x minus 3, it cancels. And you're left with negative 12 equals negative 12. Craig, do you remember what that means?
0.
Do you remember what that means when you get a true statement? It means if your variables cancel and you're left with something that it's actually true, negative 12 does equal negative 12, then that means that the answer is all solutions. It can be anything. So, any solution. What does it mean if it's a false statement? What's that? Very good. Let's say it left us with like 8 equals 12. That's no solution because it's false.
So it's either any solutions or no solution.
If the variable completely goes away. That's not going to happen very often. That was kind of a fluke. If the variable completely cancels, it's either...
Usually it's no solution.
Well, usually it's going to work out like the last one. You get like x equals 5 and y equals 2. And that's your answer. But if the variable cancels, which will happen about 1 every 10 problems, then it's either no solution or any solution.
Oh, okay.
Good question. You're logged in today, and I
What if
appreciate
it's
it.
2 out of 10?
What?
What if it's 2 out of 10?
Whatever.
You know,
All right. Discard. Scientific notation.
Oh,
Ooh. I'll tell you what.
We'll
If
just
someone
do
wants to
that.
volunteer for this one, I will come up with
I'll
another
do it.
one for tomorrow. No, I meant for tomorrow.
I'll do them all.
Cool. Remind me when I do that in a second, and I'll come up with another one for you. All right. Scientific notation. I'm going to need somebody with a calculator to help me with this.
Correct.
Hopefully someone's got one. First thing you have to do, multiply the first numbers. What's 3.5 times 4.15? Somebody with a calculator? 3.5 times 4.15. Anybody with a calculator? Thank you, sir. 13.0725. And then, who remembers the trick when you multiply the tens?
So just add the exponents.
You are all over it today, Tyler. Add the exponents. Is this problem done?
No.
Why not?
Because there's still, it's not a number between 1 and 10.
Exactly. You can only have one digit in front of the decimal in scientific notation. So I need to move this over. Now, am I making that number big? Is 13 bigger or less than 1.3?
Bigger.
It's bigger. I'm making my number smaller, which means I have to add 1 to my exponent. So that's going to be 1.30725. Very good. Times 10 to the 10th.
That was simple.
So yeah, scientific notation is really not so bad if you understand what you're supposed to do. And really, that's the case for a lot of these problems. If you know what you're supposed to do, it's not so
If
bad.
I'd known that's all I had to do, I would have probably passed chemistry.
Well, I can't vouch
I
for that.
passed chemistry.
Actually, I did pass. I passed chemistry with a 60.
All right, here we go. What's the key to this problem? Give you a hint. It rhymes with a guy named Mike Worms. Like terms, yeah.
Like worms.
Yes. 3x squared plus. Now, don't just do first problem, or don't just do first one, second one, third one. It's all about like terms. 3x squared and the 7x squared go together, and how much is that? 10x squared. Remember, when you're just adding or subtracting, you don't do anything with the variables. They just kind of stick around. 5x plus 4x. Don't do anything with the x's, just leave them. It'll be x, just 9x. You only do that when it's multiplication or division. And then negative 4 plus 4, 0. So you could put plus 0, but I'm just going to leave it off.
That's what I do.
10x squared plus
Now
9x.
what you do?
Nothing.
That'd be the answers.
Questions?
Okay. Cause that was so difficult.
Oh man, where'd it go?
Oh,
crap.
Alright, Carmen.
The other one is a subtraction problem. That's what somebody will be volunteering for tomorrow, the subtraction version of this. All right, find each product. Product. So, we are going to distribute. All multiplication is just about distribution. What's 7 times 3?
21.
What'd you eat in your bread?
That's illegal.
Man, I didn't eat anything. Maybe that's the trick. And what's x squared times x squared, Tyler?
I don't ever eat
X squared times X squared.
Yep. You did it a second ago and I told you not to, but now you do it. X to the 4th, that's right. Shh. Very good. When you multiply common bases, you just add the exponents. 7 times negative 6, Cody?
What?
What's 7 times negative 6?
7 times negative.
Actually, I'll tell you what. You do the x's. What's x squared times x? You have 2 of them, you have 1 of them, and when you multiply, you just put them together. Very good. And what is 7 times negative 6 for the first part? Negative, thank you, Cam. Okay, Cam. Negative 42x cubed. And then 7 times negative 2? I think that's negative 14. And there's only 2 x's in this, so it just sticks around. Cody. You know I'm getting your whole conversation?
They just got you saying that too.
Touche. All right. The second one. It's still all about distribution. 4 times 2. K times k squared is k cubed. 4k times 1k is 4.
How your K is so crucial.
Yeah, I should stay away from k's. It's a good thing there's no k in my name.
Okay.
4k times negative 6 is negative 24k.
Double distribute, that's right.
Yes, sir. That's exactly what we do. Because now you have to do the same thing with the negative 3. Negative 3 times 2k squared. What's negative 3 times 2?
Negative 6.
Negative 6, then the k's stick around. What'd you say?
You need to fix your phone, man. Looks like an L or something.
Look who's talking, Cody Stammen. All right. Negative 3 times k.
Negative 3K.
And negative 3 times negative 6.
18.
Negative.
I'm so sad you're leaving for the next few days. I feel like this is like just the pinnacle of productivity. All right. Now we have to Mike Worms. 8k cubed.
These don't just go together.
4k squared and negative 6k squared combined to give you negative 2k squared. That's just 4 minus 6.
Class 2.
Negative 24 minus 3 is negative 27k. And then plus 18.
It's a jacked up K.
You're a jacked up k.
You're a jacked up K.
You need to fix that.
I feel like we could just do this forever.
You're
What?
both jacked
If
up
somebody
kids.
like watches this,
Face
they're not gonna know what that is. They're gonna think it's like a backwards again.
I apologize to all those who are viewing from home, but that is a K.
He's not gonna post this one on YouTube.
Yes, I am.
Okay, that was up on slide.
And for all of you watching on YouTube, I'm talking to Craig. I am going to post this on YouTube.
I'm gonna go home and watch your Xbox tonight.
You'd better. Okay. Questions?
No, but it blew a hole out.
People are probably gonna watch this on YouTube at some point in time and be like,
I'm gonna watch it. I'm gonna watch it like later in the week and see if I can remember.
We're so
That
retarded.
teacher's an idiot. Okay.
You're still recording.
Yes, I am.
How can you say that?
Here we go. What's 24? Okay. You still do it term by term when it's only. Now, please notice. This was on the last quiz.
Is this synthetic thing?
This
Yeah,
one is
it's not
synthetic.
eight.
This one is not.
I
It's
don't know.
synthetic.
By that you mean 16 is synthetic.
Yes, 16 synthetic. V minus 7 is a binomial. When you divide by a binomial, because it's two terms, then it's synthetic. 14, however, is just one term, so it's just one, each term at a time. What's 24 divided by 6? What? Yes.
4,
4 into the fourth divided by n
in third,
into the third. So it's 4 into the third. 36 divided by 6.
6 into the second,
Just keep going, Tyler.
2 in,
Very nice. Very nice. I think you do better in the front of the room. That's what I'm learning.
pay attention to better. I can do
Okay.
it.
He's gonna put you behind the teacher desk now.
He's going to sit right here come Monday. All right. Now, when you do synthetic division, all right, more than anything we're going to review today, there are certain things that are hard, certain things that are easy, but there are also a very few number of things that are easy, but people are still missing a lot.
Oh, yeah?
Synthetic division can be very easy if you take some time to study it a little bit.
Is that the ones where you go put it in the box?
Yeah, they can really be quite simple. What number goes in the box?
Negative 7.
The creep.
7.
That's right, always the opposite. Positive 7. Now, coefficients right across the top. We have 1v cubed. How many v squareds do we have?
Negative 10,
How many v's?
25,
How many constants?
negative 28.
That's a 10. That's negative 10.
Stamina over here.
It looks like 70.
I apologize. It's negative bloody 10.
Alright,
What if I go home and watch this?
he said it's negative 30.
Fine.
I like how he slowly took it away.
Negative 10.
Oh, God.
I don't care.
The lightning,
Moving on!
negative lightning bolt. Zero.
Drop the 1. You always drop the first number. Then, you multiply 7 times 1.
7.
Wait, slow down.
I love how you can draw with a
Damn.
perfect arrow.
Alright, never mind.
I am good at arrows.
Negative
Almost.
Negative 3.
Negative
Negative.
21.
Hold on, pause. How are you getting these?
I know.
You take negative 3 times 7.
That's right. You take everything below this line and multiply. Now, where are you getting that number?
You're subtracting the top number and you're taking the bottom number.
Technically, you're adding, but yeah, since it's negative, you're basically subtracting. Very good. 25 plus negative 21.
4.
4.
4 times 7.
28. 0.
Stop.
Seriously. That's gross. All right. So, if we started with v cubed, what does our answer start with? V squared. So that's 1v squared minus 3v plus 4. Now, you're done. But, because there's no remainder, and I want you to know what to do with the remainder, I'm going to write this zero remainder like I would a normal remainder. Although normally you wouldn't have to. But when you have a remainder, you're going to throw it at the end, which I don't have room to do, but it would be plus whatever your remainder is, divided by what you were originally dividing by.
Hey,
Question.
can I do this tomorrow?
We're going to, you can volunteer for it in a second. Yes.
Well, you have.
That
what are
pink
the-
you said?
Second later, she volunteered.
What were you saying?
No, no. So like, say like the number on the bottom,
Yeah.
Change signs. Would you change the sign of the problem?
What do you mean? Like one of these?
Like, you know, like the negative 3. You got this negative 3. What if it had been like, instead of coming out as negative 3, coming out as positive?
It'd be plus 3.
So you just change.
That's where that goes. See, positive, negative, positive, positive, negative, positive.
So you just change the signs on that.
Yep.
Whatever's on bottom.
Yep. It is what it is. Questions? Man, I feel like we are rocking and rolling today. I'm feeling good.
Alright, Stamina, calm down.
All right. Factor. Oh, brother. I hate factoring. Factoring. Now, I'll tell you. Read the directions.
oh, really?
It just tells you. It just tells you to take out the common factor. Shh. So which means all you have to do is take out what's common in each one. You don't actually have to do all that factoring stuff.
1.
Well, is there a number that goes into 56, 28, and 63?
What's that?
One.
Is that a hiccup?
Yes, it was.
7.
7.
So does 1.
Now, 7 comes out of the numbers. What's the smallest number of m's we have available?
M to the
3. Or M's?
M.
5.
5. And what's the smallest number of n's we have?
1.
1. Yeah, the first one. So, here we go. Negative 56 divided by 7 is negative 8. 7 m's minus 5 m's is 2 m's. And we took away the only n we had, so we're done with that one. Plus, 28 divided by 7,
4.
nice. 6 m's divided by 5 m's, 1 m. And 3 n's divided by 1 n, okay.
And you keep saying about is it minus?
Well, you subtract the exponent. Technically, it's division, but yeah, you subtract the exponents. Negative 63 divided by 7, what'd you say, Mark? 9. What?
It'd be 9 N.
Very good. Why wasn't there an M?
Because it cancels out.
Because they all canceled. Very good.
That's all you have to do.
Yep. Now,
He did jump.
these you have to actually factors. Now, I've given you one of each. One of each. I gave you a quadratic, a perfect square, and a grouping, all in one. And I may have told you the order. But what is the first step to any factoring problem? What is this first step to see what's common, see what comes out? What comes out of the first one? A 6. So that'll be 6 v squared minus 3v minus, I think that's 18. Minus 18.
Is that 61?
No, it's a 6 parentheses. 6
Oh my
parentheses.
God.
Thank you, sir. Now, this is the hard part. Who remembers, actually, don't forget, I showed you how to do this on the calculator. If you graphed this, it would cross at like, I don't
Can you graph it without doing anything to the problem?
yeah. And if it comes out even, here's the thing. Actually, let's finish it and then I'll explain it. All right, if the last sign is negative, what does that tell you? It tells you that your factors are going to be what?
Negative and positive.
1 positive, 1 negative. Now, what is if they're different, what does the first sign tell you?
But the smaller ones will be negative.
Yeah, the bigger one. The bigger one's going to be negative. So now we have to look at the factors of 18. 1 and 18, 2 and 9, 3 and 6. And we know the bigger one is negative and the smaller one is positive. Which of those add to negative 3? Yes, plus 3 minus 6. Now, if you had chosen to graph this problem, if you had chosen to punch this in and graph it, it would have crossed the axis at negative 3 and positive 6. If you graph it and it comes out really even like that, then that just means the answer will be x plus 3, x minus 6, but there will be a 6 pulled out. If it crosses evenly and there was a leading coefficient, then that means that's just going to be out in front. So, plus 3, minus 6.
A leading coefficient we need.
No, I won't give him any attention.
What's the main leading coefficient?
That's the number out front.
It's just the first number there?
Well, technically, it's the number
It's the smallest?
it's the number attached to the highest degree.
Okay.
Okay? All right, number 22. Now, you could graph number 22 as well, and it would cross for you. But that is a difference of 2 squares, which is hopefully something you'll notice. That is x squared minus 6 squared. Difference of 2 squares break down into x plus 6. Yeah. If it was x squared minus 9, that'd be x squared minus 3 squared. That'd be x plus 3, x minus 3. Difference of 2 squares. But you could just graph it and it would cross at 6 and negative 6. Yeah. Actually, yes, I will. I will. Yeah. I'll put those formulas on the board Wednesday. 24. Grouping. If it's 4 terms, it's pretty much always going to be grouping. I should change colors. Now, it did not apply on this one. But what would we have had to do if this had been a minus sign?
Change it.
Change the last one, this one, we would have to change that sign. But it didn't apply here, so never mind.
You did change the first one too, wouldn't you?
No, just the last one. Because that's the one. If this had been a minus, and we had put this in parentheses, then that technically would have been like changing how the distribution worked, and that's the only one you have to change. Just the
You
last one.
wouldn't change the positive 49 to a negative 49?
Why? Would you do that?
No, if it was already minus, if it had been a minus, then it would have already been negative, right? But when we put it parentheses, we would have already kind of changed it to positive, just by putting it parentheses. If this had been a minus, and we put in parentheses, that we would be kind of severing that minus.
Right.
Therefore, we would have changed it, which is kind of the point. But then we would have also had to change this one, which is why you change that sign, and why that's the only thing you have to do. So,
But no,
you want to work one like that?
Yeah.
I'll tell you what. We're going to change this problem by just a little bit.
Yeah.
To help answer your question, we're going to change this problem. We're going to change it to a positive minus minus. We're going to change it to that.
What was it? Minus, positive minus?
Yeah, but we're going to change it to plus and oh, I'm sorry. Here you go. Can you pass that back, please? All these answers will be online for you. You can copy them down later.
What is it?
It's a test review, but I'm taking it up Wednesday for a homework grade. We're doing half of it today, half of it tomorrow.
When's the test?
Wednesday. All right. So if that's a minus, now Tyler, this is what you were asking.
Then I'm a plus.
If that's a minus, then you change this to a plus.
right.
Okay, so what factors out of the first one?
Wait a minute, it's a minus, you change it to a plus?
No, if this is a minus, which it now is because we changed it, then you just change the last sign, regardless. It was negative, so we changed it to a positive.
You'll always
Would you
change the
change
first sign.
49 to negative?
It's already changed. See, it was, before I put the parentheses on there, it was minus 49. It was negative. But now that I put parentheses, it's kind of separate. So we kind of already changed it to a positive just by putting the parentheses.
But it was
Which is why the only thing you really have to remember is that when that's minus, just change that sign.
So you
Because the
don't have to make
parentheses
it-
already do the first one.
So you don't have to make the 49 negative?
No.
So what about, so if it's positive, does that make the 42 positive too?
If this was, you mean if this was a plus,
Yeah.
then you wouldn't do anything. You just put them in parentheses. All right. What factors out of the first one?
1.
2x.
2x. Very good.
I'm going to keep this and that's how I get it right.
It's never going to be right.
Wait, what did it say?
1. All right. So if you take out 2x, it'll be 7y.
7.
And 12x divided by 2x is 6. Minus. What factors out of the second one? What number goes into 49 and 42?
7.
7. And can we take out a y?
Yeah.
And that'll leave you with, let's see, 49 divided by 7 is 7. Y squared divided by y is y. 42 divided by 7 is 6. And it's plus because I changed this sign to a positive. Are our pieces the same?
Yes.
And they should be if you do it correctly. Now all you have to do is bring that down and combine the pieces in front of them. 2x minus 7y, and that'll be in parentheses as well. And it's now kind of one big multiplication problem. Again, that comes down here, and this comes down here. Questions?
26. Let's go.
Oh, there's only 26 on here? There's only one more?
All the way to 28.
Oh, two more.
And they're both the same thing, basically.
Oh, sweet.
It's point slope.
Oh,
What's that go to?
Not really.
we'll do it.
Not really, but kind of, you know.
I don't know.
About 4.
We will do it.
Proper.
Cody.
YouTube.
Woohoo!
I'm sure you're saying all that.
All right.
I guess so. I put this one in YouTube.
All right, this one, graphing inequalities. You're just going to graph them like normal lines, but then at the end, you're going to have to shade. What's the y-intercept of the top line?
Y intersection.
3. What is the slope?
2 over 1.
2 over 1, so up 2 over 1. Connect your dots. But what kind of line should this be?
Dotted.
Why should it be dotted?
I don't remember, but it's supposed to be dotted.
Because there's no equal sign. It's just greater. If it was greater or equal to, it would be a whole line. So very good, dotted line.
Got it.
The second one, what's the y-intercept? -2. What's the slope?
Down 2 over.
Looks like it's still positive 2, right? So up 2 over 1 again. Looks like these lines are going to be parallel.
So second, so the x is your slope and the y is your,
The number with the x is your slope. The number by itself is your y-intercept. That's where it crosses the y-axis.
So it goes on the 5.
-2, positive 3.
I don't
Now,
know if she'll get it
we are shading y is greater than, so we're shading above the top one, and y is less than, so we're shading below the bottom one. You know what's interesting? I'll be curious to know. Some people would view that as no solution since there's no overlap, but, and if that's the case, I'll tell you when the time comes. I'm not sure how they'll want this, but we're going to go ahead and shade where we're supposed to. Above the top one, below the second one. Although that may be no solution according to them, since there's no overlap in
where do you
those
shade there?
places. Because this is the first line, but it says y is greater than, so that means above that line. And this is the second line, and it says y is less than, so we shade below that line.
So if it's greater than, you're shade above it.
Yep.
Same as below.
That's it.
Make us do this one on our own.
Well, you're going to do those tomorrow. You'll do problems on your own tomorrow, so we're just going to keep going. All right. And I need to hurry up and do the problem draft. 28. What's the y-intercept of the first one?
3.
+3. And what's the slope?
2 over 1,
Well, that looks familiar. Dotted or solid?
got it.
Very good. What's the y-intercept of the second one? -2. And what's the slope? So up 1 over 3, and that'll be a solid or dotted?
Solid.
Oh, I didn't draw this very well, but oh well. Now, we are shading above the first line.
It's in that corner down there.
Dang it, you're right. Crap. Oh well.
I can fix it.
Solid.
Above this line, below this one. The only place where that overlaps is way down here in the corner.
There you go. I like it.
Above the second one, above this one, and below this one. And the only place that happens is way down there in the corner. Down. Yeah, right. Who's really going to look at this? Nobody. Except for maybe people in this class. All right. Questions?
Why is it way down the corner?
Because, just like last one, where's the only place that is both above this line and below this one? And that's right there. It's the only place. Because if we had shaded here, that'd be above this line, which is false. If we had shaded anywhere else, it would have contradicted one of those two things. That is the only section that's above this line and below that line.
Have you stopped recording?
I wish, not yet, I wish it had given us this region so it'd be easier to see, but it didn't. All right.
Hey,
Cut it
Yes.
off.
what is 17?
We'll get to that.